Hello, this is Dr. Ayenshola Ogundele, Astronautics for Exploit. 21st Century Initiatives of Space-Based Solar Power System. The focus points of my presentation are as follows. 21st Century Space-Based Solar Power Initiatives, Space Solar Power Initiative, SSPI, Cassiopeia Space-Based Solar Power Initiative, and Energy Orbit. The 21st century, the present century under the Gregorian calendar, and which began on January 1st, 2001, and will end on December 31, 2100, as witnessed and is still witnessing various notable events. Some of these events are rise of global economy, astronomical increase in private companies, both space and non-space related, technology evolution brought about by the digital revolution, globalization, inventions such as smartphone, cryptocurrency, social media, capsule endoscopy, solar-powered car, electric and driverless cars, 3D printing, and a host of others. In this 21st century, space-based solar power system, which was initially thought to be non-economically viable, has been recognized as an essential system necessary for the actualization of the continuous expansion of humanity's existence across the universe for many years in the future. In a bid to increase energy independence and reduce greenhouse gas emissions, various countries around the world are investing in the development of technologies that will aid the advancement of space-based solar power, which was forecasted to be a potential solution to our energy needs. In the present century, various space-based solar power system sponsored studies, proposed ideas, and innovations were planned and carried out. In 2001, National Space Development Agency of Japan announced a plan to carry out research and prototyping of space solar power system by launching an experimental satellite with 10 kilowatts and 1 megawatt of power, and in 2003, ESA commissioned studies on space solar system. In 2010, the Indian Space Research Organization and the U.S. National Space Society launched a joint forum to enhance partnership in harnessing solar energy through space-based solar collectors. In 2016, Lancash of Seco Design proposes Cassiopeia, constant aperture solid-state integrated orbital phased array, a new concept of solar power system. In 2019, a concept of energy orbit, a small space solar power satellite constellation for power beaming between satellites in low Earth orbit with a total of 1,600 satellites to transmit 10 kilowatts of electricity in a 500 kilometers radius at an altitude of 900 kilometers was proposed. In 2022, the Space Energy Initiative announced the intended launching of the first power station in space during the mid-2040s. For the successfulness of the solar power system, the following are needed to be put in place on the Earth: ground receiving or rectifying antenna, known as rectenna, and its interface with the power authority network, launch facilities needed for the transportation of the construction materials from the Earth to the orbit, and provision and control functions, and industrial facilities needed for the production of the materials and components that will be assembled into a solar power system. 21st century space-based solar power initiatives are as follows. In 2001, NASA announces plans to perform additional research and prototyping by launching an experimental satellite with 10 kilowatts and 1 megawatt of power. In 2015, the Space Solar Power Initiative was initiated. In 2015 also, JAXA announced on 12 March 2015 that they wirelessly beamed 1.8 kilowatts 50 meters to a small receiver by converting electricity to microwaves and then back to electricity. In 2016, plan to exploit atmospace for industrial development, such as construction of space-based solar power satellites that will beam energy back to Earth was developed. In 2016, Lancash of Seco Design proposes Cassiopeia, a constant aperture solid-state integrated orbital phased array. A new concept of SPS was proposed. In 2017, NASA selects 5 new research proposals focused on investments in space, and one of them was based on the 21st century trends in space-based solar power generation and storage. In 2019, Aditya Baroska and Professor Toshiya from Space System Dynamics proposed an energy orbit, which is a small space solar power satellite constellation for power beaming between satellites in low Earth orbit, and a total of 1,600 satellites to transmit 10 kilowatts of electricity in a 500 kilometers radius at an altitude of 900 kilometers. In 2019, a test base for space-based solar power was proposed and planned to launch a working megawatt grade 200 tons. In 2022, the Space Energy Initiative announced the launching of the first power station in space during the mid-2040s. And also in 2022, there was a plan to launch several solar power satellites under the name Solaris. Space Solar Power Initiative. The Space Solar Power Initiative was a collaboration between Kethek and Crewman, and it was aimed at developing a system of lightweight solar power towers which can convert solar energy to radio waves and can be placed in orbit to beam power to the Earth. The research concept. SSPI is a multi-year research concept which was being designed to build ultralight model system compatible with today's launch costs. The picture here shows illustration of the SPS Alpha solar power satellite by means of arbitrarily light-phased array system beaming energy. Space Solar Power Initiative approach involves development of enabling technologies, development of ultralight deployable space structures, development of high-efficiency ultralight photovoltaic, and development of phased array and power transmission. The picture here shows gigawatt scale baseload solar plant on a satellite. The other approach are integration of concentrating PV radiators and power conversion and antennas in single cell unit, localization of electronics and control for system robustness, electronic beam steering, identical spacecraft flying information, and target a specific power over 2000 watts per kilogram. The picture here shows an artist representation showcasing the capture of solar energy in space and being precisely beamed to where it is needed through the Space Solar Power incremental demonstration and research. The idea of Space Solar Power Initiative is to develop the technology that will enable one to build the largest ever built space structures. The idea for beaming solar energy to Earth from space is ingenious, simple, and has the potential of being successful if it gets necessary investment and financial assistance. The picture here shows illustration of the idea of space-based solar power, a feasible and competitive renewable energy source. The modular approach. SSPI is based on a modular approach which ensures low cost and redundancy. The basic unit is a multifunctional thigh, a lightweight photovoltaic segment that measures 10 by 10 centimeters and is only 3 centimeters thick, weighs about 0.8 grams, and can flatten when assembled for launch. The picture here shows 2,500 orbiting solar panels, which could provide Earth with limitless power. The carpet satellites. 400 of the basic tiles are assembled into panels with 900 parallels per satellite, and each of the carpet satellites can be folded into a small space for launch and unfold once in orbit to its full size, about to touch the size of a football field. The closed formation satellite. The concept involves 2,500 of the satellites flying in a closed formation, forming a solar power surface of 9 square kilometers. The picture here shows demonstration of Space Solar Power Initiative. Cassiopeia Space-Based Solar Power Initiative is another initiative of 21st century. Cassiopeia is a project designed to launch a constellation of very large satellites in a high Earth orbit. Once deployed, the satellite will harvest solar energy and beam it back down to Earth. Cassiopeia satellites. Its satellites will be made up of hundreds of thousands of small, identical models produced in factories on Earth and assembled in space by autonomous robots, who will also carry out servicing and maintenance. The picture here shows Cassiopeia, a prototype satellite solar power design. The solar energy collected by the satellite will be converted into high-frequency radio waves and beamed to a rectified antenna on Earth, and this will convert the radio waves into electricity. Each satellite is expected to deliver around 2 gigawatts of power into the grid, making each satellite comparable in power output to a nuclear power station. The picture here shows Space Energy Initiative. Cassiopeia can be launched onto various orbits so as to collect sunlight and efficiently convert it to a safe beam of microwaves directed to a terrestrial rectified antenna, which is known as rectenna, feeding into the local power grid. Cassiopeia is a renewable carbon-free system which could augment and eventually replace traditional terrestrial power stations, de-risking the pathway to net zero. The picture here shows Cassiopeia space-based solar power initiative demonstration. Energy Orbit is another initiative of 21st century of space solar power system. Energy Orbit is a proposed small space solar power satellite constellation for power beaming between satellites in low Earth orbit. A total of 1,600 satellites is being envisaged to transmit 10 kilowatts of electricity in a 500 kilometers radius at an altitude of 900 kilometers. The ERB project consists of phases for developing a demonstration mission to support 3,200 satellites in low Earth orbit and optional support for up to 9,000 satellites. These phases are divided into 4 phases. The picture here shows demonstration of beaming of electricity down to the Earth from satellites through microwaves. The energy orbit idea entails development of a constellation of ESAT called energy orbit to supply sufficient power to spacecraft within the range. E-orbit project is designed to increase the impressive performance and operational lifetime, especially for small and cheap satellites using microwaves and laser-based power transmission. The picture here shows space-based solar power involving harvesting sunlight from Earth orbit and then beaming it to the surface where it is needed. The objectives of E-energy orbit are to generate, convert, and transmit electricity in space using laser-based or microwave system with the concept of space-based solar power system. By developing small satellites and creating a constellation of the eSat to create an e-orbit in space. To demonstrate the capability of high power generation in a compact design using a concentrator and bifacial PV solar array. Illustration of space-based solar power concept is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to 21st Century Initiatives of Space-Based Solar Power System presented by Dr. Ayeshola Ogundele, Astronautics for Exploit, with the focus points 21st Century Space-Based Solar Power Initiatives, Space Solar Power Initiative, Cassiopeia Space-Based Solar Power Initiative, and Energy Orbit. Thank you.